Hey, what's up, guys? Thank you so much for checking out this video. As you know, OpenAI just released Codex hours ago. Now, this is an open source coding agent that runs entirely within your terminal. Now, because it's open source, I figured I want to check out the GitHub, take a look through its code, and understand how it works. And I figured, why not do that using Codex itself? So let's get straight into it, understand the software architecture behind this project, and have some fun along the way. All right, so as you can see, I'm here on the GitHub repo page. So the first thing I'm going to do is actually install Codex onto my local machine. I'm going to copy this right here, go over here, paste the code in, and let's start installing Codex. Make this a little bigger so you can see. Okay, now next thing I'm going to do is I need to clone this repository itself. So I'm going to go up here, code. I'm going to copy this. I'm going to make a directory. Actually, let's see. I'm going to change it to my dev directory. And I'm going to git clone codex.git. Now what we're going to do is we're going to go into the codex directory. And now that we're inside this directory, we're going to see how we can actually get codex running. Now I've already exported. Now if you look over here, I've already exported my OpenAI API key. It's already in my environment set in the environment variable. So you got to make sure that you do this step or else it's not going to work. And then supposedly we can just run Codex interactively by typing Codex. Wow, this is pretty cool. Now, I've not done this before at all, so honestly, it is quite exciting. Looks like we're running with O4 Mini. And let's just see if it understands like what directory we're in. What directory are we in? See what command. So it just did pwd, print working directory. It sees it's in Codex. Okay, what's that? So it knows it's in its own directory. It's kind of funny to think about this, like that it's just running in its own directory. And um, so it says you're sitting in the root of the Codex repository. That's the top level directory for the open source Codex CLI project. You'll find things like Git, blah, 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 blah. Okay, so I'm going to tell it here that I want to understand the architecture of Codex and how it works. So let's just do it. I want to understand the architecture of Codex and how it works. Please explain the main software architecture points based on your assessment of the repository. Let's try that. So, okay, it's looking at the docs, Codex CLI. Now, while it's thinking and doing all this stuff, I'm going to go ahead and tell you that I'm going to show you what I was looking at earlier. I was over here on the page. I went into Codex CLI. I went into source and I just noticed, I went into app.tsx. Now this is kind of a app.tsx is I'm blanking on the word for the, it's like a TypeScript file for the mainly like React components, JSX file for JavaScript. And this, so this file is really defining the actual terminal interface that I'm interacting with over here on the left. And it's not defining like the actual agent logics as far as I can tell. But let's take a look what it actually says here in the output layer. So here's a high level tour of, well, actually, I'm kind of curious what all it did. So I'm going to scroll up a little bit here to see from my query. So I looked at the docs, looked at Codex CLI. It did this sed command to look at the package.json. It looked at app.tsx, okay, which is what we're looking at over here. It looked at the terminal chat file. It looked at, now it looks like it's doing something here, which I don't know if this is limiting like a certain number of lines potentially. I'm kind of curious what these, oh, no, mouse stopped working. Kind of curious what these, what that means there. But anyway, so it looks at that file, it looked at the agent loop. Okay, here we go. So this is really exciting, right? So it found this utils agent loop.ts. So this is going to be at the heart of the agentic kind of logic within the file, within the application. And so I'm sure that there's a lot inside there that we can learn from. So later on, I'm going to go into that file and take a look. It looks like it's searching for some kind of, okay, so it's finding this function definition public async run that's within the agent loop file. Lots of stuff in agent loop. Okay, so here's a high level, so it looks at the agent loop file a lot, and then it's giving us an actual answer to the question here. So high level tour of the Codex CLI's architecture, how the pieces fit together, project layout, README, Codex CLI. Okay, that's the actual NPM package. TypeScript source, blah, 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 blah. Entry point, okay. Bin, codex, this, that's where the compiled, JavaScript entry point is. All the TypeScript codes gets, compiled into JavaScript for distribution on NPM, which is the node package manager. Now, okay, here we go. The interactive UI layer, as I was mentioning, the app.tsx file, that's the actual terminal interface that we're actually working with here on the left of the screen, I guess that way. And the terminal chat. So this handles the message history, input box, overlays. Now, agent core, interesting. Orchestrates every turn with the LLM via the OpenAI Responses API. So they're using the Responses API, which is one of their new APIs. The prior chat APIs and completions APIs are no longer this state of the art. So it streams tokens, emits response items to the UI, handles function call events, our shell tool, queues up tool calls and waits for user approval per policy, retries transient errors, services rate limits, and context to large errors, tracks last response ID and pending aborts so cancellations remain consistent, approval policies, suggest, auto edit. So this is where if it wants to make a change to a file, it asks you first if you're not in the autopilot mode. Okay, tooling and execution. Functions shell describes a JSON schema to OpenAI. When the model invokes it, HandleExec command. Let's actually, I'm pretty curious. I want to actually just go in here into the agent loop to actually see these functions. So for example, HandleExec command, let's find that. HandleExec command. Looks like it's defined here in this file inside of same directory HandleExec command. So it looks like it's taking arguments, some configuration, some kind of policy about authentication and sandboxing. There's some kind of command key that they're using, running the command in a sandbox, actually executing the command and getting a summary. And now at some point this is defined, as a tool. So I'm gonna see that later. But okay, let's go to the next thing. Utilities and helpers, config, session, check-in, models, fetches available models, input utils, wraps users, single pass mode, blah, 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 blah. Okay, in essence, Codex CLI is a thin React Inc. front end driving an LLM-backed agent loop that can call back into your shell and file system as first-class tools, all wired together with careful streaming, cancellation, and user approval logic. Let me know if you'd like to drill into any specific part. Okay, that's a great summary. Amazing. Now remember, this is using, I believe, O4 Mini as the AI backend. So let's say I want to see exactly where the agent tools are passed to the API. Because that's kind of what I'm interested in, is how do they actually, take these tools and the shell commands and actually package them for the AI. So let's see where that's happening, if we can pin that down and see how they're doing that. Okay, so the LLM tools are injected right at the API call in the agent loop's run method. Open up agentloop.ts and look around line 518. So, let's go back. Let's go back to agent loop. Go to line 518. And okay, oh nice. Okay, this OpenAI.responses.create. Perfect. So here we can actually see the call. I don't know if you guys can see this. Let me try and make this bigger. So stream equals await this.openai.responses.create, and you can see that we pass in the model instructions. I'm gonna have to take a look to see what this merge instructions kind of object is later, but you can see here that this is where we define the tools, right? So it's a function, it's named shell, and it runs a shell command, returns its output. Now, one of the beautiful things about this is that, as you can see, they are only using one type of tool, and that's the shell command, right? So this is an agent that's running locally on your computer. It's only issuing shell commands locally, and it's not using any other tools. This is the only tool that they're providing to it, which is really cool. It kind of shows how powerful just, having access to the shell can be. It's not, using any other custom functions or any other bash scripts or anything like that. And so it has this, parameters object which specifies which parameters need to get passed to the command. It's an array of strings, which are just the shell command arguments, obviously. And it looks like, it also has the working directory and timeout maximum time to wait. And that's pretty much it. That's incredible. Okay, so look around this line and we see all this. The tools array is exactly where the CLI tells the OpenAI API about the shell function, where you'd add any other tools. So that's pretty much how it works, and it's pretty cool. Now, I'm gonna take a look a little bit more. I guess that's pretty much it. Am I interested in any other aspect of this? Like, let me just ask you, what else is interesting about the architecture of this from the agent perspective? You know what? Now, as I'm asking that, I think I thought of my next question, which is, how does it actually plan a task, right? So when a user asks a command about the code base or asks to modify some code, does it actually just does it make a plan of, okay, this is what I actually need to do, and then it goes through steps to implement that, or does it simply just pass that query straight to the API? And on top of that, what is the system message? Like, is the system message being configured somewhere here in the repo that's telling it it's an AI agent that's running in a terminal app? So these are really important questions that that I do want to get an answer to. But first, let's see. Here are a few more deep cuts and neat design patterns in the agent side of Codex that you'll often not see in more straightforward wrappers. Streaming and staging. Okay, generation counter. Every time you call run, a private generation counter is incremented. All in-flight events, check if event.generation does not equal current before staging, so you'll never see stray tokens from a previous turn after a cancel. Okay, that's interesting. Sounds like, because it's like streaming tokens, it's keeping track of the most recent stroke token that should be streamed. cancellations and pending aborts. Canceling via agent.cancel aborts both the stream and any pending shell commands. If you canceled after the model already emitted a function call, Codex buffers its call ID and pending aborts, so the next request can automatically supply a dummy function call output. This avoids no tool output found errors. Okay, that's kind of interesting. Tools as functions. In the single call, you declare your shell function's name. When the model emits a function call, the loop hands it off to HandleExec command, which parses apply patch commands and stages them via git. Executes arbitrary shell with sandboxing, returns output text plus exit code as a function call output. So it seems, based on what this is saying, it seems like it actually stages changes with git before it runs any shell commands, potentially, if I'm interpreting this correctly, which was obviously good for reverting changes back to your repository if you see any unwanted changes after you're running the commands. Now, please correct me in the comments if I'm not interpreting that correctly. Then we have error resilience and retries. The retry loop around the OpenAI call tolerates timeouts, 5x, x, like 504 or 5, whatever those timeout errors are. Rate limit, streams, constructs. Okay, two-phase function call handling. Streaming events drive an optimistic live UI. On response completed, it falls back to a non-streaming code path to catch any missing function calls and ensure you never lose an exec step. Not sure exactly what that's talking about, to be honest with you. Prefix injection for self-awareness. At the top of the file, there's a big prefix constant with embedded instructions reminding this code that it's operating as and within the Codex CLI. Okay, it even notes about Codex help, get back, rollback, and the requirements to terminate only once a task is complete. This is how it stays in roll. So let's explore this last part a little bit more. I know the video is getting a little bit long, but I'm pretty interested in this. So regarding your last statement about how it knows its role, can you explain that further, as well as answer, is there a system message defined somewhere? And, okay, wait, that explains the context. And is there, actually, let's just start with that. Let's start with that. See what it says. I'll make this a little bit bigger here. Move this over. So it's looking at configs, looking at utils. Anyways, if you like what you're seeing and you want to see more tech videos, exciting AI videos, healthcare videos, informatics, and you want to hear it from someone like me, hopefully, then please hit that subscribe button, hit the like button so you can support me. And we'll go on this journey together to Terminator. I'm just kidding. To AI, what's the word? Utopia. So anyways, here we go. So digging into the LLM call in AgentLoop, you'll see that Codex never builds a messages array the way a chat completions wrapper would. Instead, it uses the newer Responses API, which takes an instruction string, think system prompt, plus an input array of user/tool messages. I see. System prompt equals the hard-coded prefix. At the very bottom of Codex CLI source utils agent loop, you'll find const prefix. Perfect. You are operating as and within the Codex CLI, terminal-based agentic coding assistant built by OpenAI. You're an agent. Please keep going until user query is completely resolved. The entire blob is prepended to every request as instructions. It tells the model what its identity and capabilities are, what it can call, or that it can call tools, that it must keep going until the problem is solved, where to find Codex help, the Git sandbox, etc. Okay, so this is a critical point about the architecture. Because they are using the Responses API, which is a new API from OpenAI, there is no longer a system message. It's been replaced with this instructions field inside the API call. So I'm going to go back over here real quick and find that prefix inside the code base so that we can actually take a look at it. So here it is right here in front of us. And this is basically what the system message was before, right? And instead it's here in the instructions getting passed as a prefix. It's telling it, the agent, that it can receive user prompts, project content, files, stream responses, apply patches, work inside a sandbox, telemetry. It's telling it what it is. You are an agent. Please keep going until the user's query is completely resolved before ending your turn and yielding back to the user. Only terminate your turn when you're sure that the problem is solved. If you're not sure about file content, use your tools to read files and gather the relevant information. So this is really cool. So this, this is basically outlining here, how do you teach an AI agent to operate on your file system? They're showing us exactly how they're doing it with this file, with this prefix variable inside the AgentLoop.ts file. So you can basically see here, working in the repo is allowed, analyzing for vulnerabilities allowed. They're explicitly telling the agent that these things are allowed, probably because in their testing, I'm assuming that sometimes, it'll respond like, oh, I can't do this or I can't do that, because of all of the biases that these agents have after, or that the base models have after being trained on a corpus of text, right? So they have to be instructed that they particularly can do certain activities. So here's an interesting thing. If completing the user's task requires writing or modifying files, your code and final answer should follow these coding guidelines. So they actually have coding guidelines right here. Fix the problem at the root cause rather than applying service level patches. Avoid unneeded complexity in your solution. Update documentation. Keep changes consistent with the style of the existing code base. Never add copyright. You do not need to git commit your changes. If there's a pre-commit, once you finish coding, you must check git status to sanity check your changes. Interesting. Revert any scratch files or changes. Remove all inline comments you added. Check if you accidentally added copyright. Sounds like that was a problem they encountered, so they had to add this. If completing the user's task does not require writing or modifying files, respond in a friendly tune as a remote teammate who's knowledgeable. Your task involves writing or modifying files you've already written, unless the user explicitly asks for them. So anyways, here you have it. This is one of the really core features of the architecture. Now, let's see if there's anything else here that we want to ask it before we wrap up. Wow, I kind of messed up my terminal over here on the left. Anyways, let me see if this terminal app is even working anymore. Okay, thank you. Let's just tell it thank you. So thank you guys for watching this video. If you liked it, like I said, like and subscribe. We got a little bit of insight into the software architecture of Codex, and I'm super excited to not only just use Codex, but also use this and the way that they're actually building their agent loop in order to advance my own AI projects. And maybe in another video, I'll actually get into the architecture of how they handle the user messages and the function calls and all those things like that. And thanks again for watching. I really appreciate you guys. Please subscribe so you can grow my channel and we can stay on this journey together. So take it easy. Peace.